The final lesson that we're going to be doing in Unit 2 this year is going to be Lesson 12, and those practice problems that are going to have to do with using those graphs to compare relationships. So the first thing we're asked to do is to match each of these equations over here, whoops, with the graphs. So let's take a closer look to those graphs. And we should know by now that the constant of proportionality is going to be where 1 is on our x-axis every single time. So we're always going to go straight to the 1 and then go up to this point and figure out where it is. Now, when I downloaded these, or uploaded, to this website, they didn't come in as clear as we'd like, but I know that you have copies of these in your book, so you can look directly at them. But here we know that K is right here, so if we have to go across, if you count up the number of horizontal lines, you'll notice that 1 is at the 5th line. So there's 5 parts. This point is at the 4th one of those parts, so that would be K equal to 4/5. And then when we write the equation, we know that it's always Y equals K, in this case 4/5, X. And you can see that that one is right there. So we know that 1 is going to be equation B. Okay, the next one that we have, again, we're going to go straight to the 1. And in this case, the 1, where the x is 1, we go up. And in this case, if we count the number of spaces between the 1 and 0, there's 3. So in this case, K would be equal to 2/3, because there's 3/3, and our point is at the second of those. So here our equation would be Y equals 2/3 X. And that, of course, is right here. Our next one, we've got, if we look at the 1, we know that first thing we want to do, as always, is see how many how many spaces there are between 0 and 1. In this case, there's 3, and our point is the one above it. You see it right there. So 3/3 plus another third would be 4/3. And that would make K equal to 4/3. And our equation, therefore, Y equal to 4/3 X. So our third graph would be E. Oh, I forgot to label the last one. No big deal. Can go right back and do that. That graph number 2 is D. Of course, this is the point where I notice that I actually didn't circle the correct one over here. As you can see, I circled B instead. So it's not B. It is, in fact, D. I apologize for that confusion. I'm sure you must have been wondering what went on. Hopefully you continued to listen and didn't just skip through, as I know far too many of you like to do when you go through these. Okay, next one, we're on to number 4. Again, same thing that we've been doing. This is our 4th graph, and we're going to look directly at where the 1 on the x-axis hits. It's right there. You see how many spaces there are between 0 and 1. In this case, there happens to be 4, and K is on the first of those, so K is equal to 1/4. Therefore, my equation is equal to Y equals 1/4 X. Now we've got that C. 4, of course, is equal to C. 5, we've got our fifth one. Let's take a look at this. Where's our 1? Well, if we count up, we can see it's exactly where the 2 is, so that's an easy one. K equals 2, so y equals 2x. And our final graph, which hopefully just works out, but we should always double check. I go to the 1, I look up to where this point is, and I can see that my 1 has only got 2 spaces in between, and this one is right in the middle, so that's 1 1/2, or 3/2. That's what k is equal to. K equals 3/2, so therefore y equals 3/2 x, which is right here, and that, of course, is F. And I did the same thing again. That's really funny. Number 5, in this case, was A. Okay, so just to recap, we know that practice problem, for this first practice problem, we know that A was equal to graph 5. I'll put that here as well. B is equal to graph 1. C is equal to graph 4. D is equal to graph 2. E is equal to graph 3. And F is equal to graph 6. Next one, we've got 2 graphs showing some data from a coffee shop menu. One of the graphs shows cost in dollars versus the drink volume in ounces, and the other of the 2 graphs shows calories versus drink volume. Which graph is which? And then give them the correct titles. Well, let's see. We know that volume is on the bottom for both of them, and we need to decide what is on the y-axis, what's represented on that y-axis. So, in this first one, we see that our numbers just go up by 1, 2, 3, 4, 5, and 6, and we've got these points here. And in this particular graph, we're hit 350 for 24 ounces. So, being logical here, I'm sure that coffee, of course, is not $350 for those 24 ounces. So this one over here should be calories versus volume. And that would mean that calories is here on the side, which, of course, I know looks terrible when I write it using the stylus. And the first one is cost versus volume. And we'll label it up the side, cost. Next, I've transferred those labels over, as you can see. Which quantities appear to be in a proportional relationship? Well, I already did start looking at these a little bit. You can see that these, even if I tried to make a line through here, through the 2 of them, it would hit somewhere up here. I'm assuming that upfront cost is, their overhead to pay for their employees and such. And then this one appears to be in a proportional relationship. So it would be, the answer here would be calories versus volume. How do we know? Well, simply it goes through the origin. So the graph goes through the origin. Then for the proportional relationship, which in this case we know is calories right here, find the constant of proportionality, and what does that number mean? So we know we would go to the 1, and we see it would hit somewhere in here. So that's hard to tell. So we give it's the point that's actually given In this case, it's the 10 to 150. So of course I would then divide 150 divided by 10. I can cancel out those zeros. That gives me 15. So therefore the constant of proportionality is 15. And I know that that tells me for every 1 ounce of coffee is 15 calories. Next, we have Lynn and Andre biking home from school at a steady pace, which that means constant, just to be clear. Lynn biked 1.5 kilometers, taking 5 minutes. Andre biked 2 kilometers, taking him 8 minutes. Draw a graph with 2 lines for the bike rides, and then for each highlight the point with the coordinates 1k and find k. Okay, so when I think about making this graph, I know that time is always on the bottom because it doesn't make sense otherwise. Time, so therefore this would be distance. And I'm just sketching it out right now. You should, of course, use graph paper and a ruler to do this, but I just, like I said, want to get started. And then, of course, just so you understand, there's going to be 2 separate lines, one for Lynn and one for Andre. So, the other thing that I want to be clear is our constant of proportionality. That's what they're asking us to find here when they ask us to find k for each of them. So remember, we know that the rate is always distance over time. So we could actually find that out right now without even going to the graph, but then check it on the graph. So for Lynn, we know that the distance is 1.5, and that's in 5 minutes. 1.5 divided by 5 is going to equal 0.3 or 3/10. That's the constant of proportionality for Lynn. And then if I do the same thing for Andre, Andre went 2 kilometers in 8 minutes. I can right now go straight to my calculator, but I should recognize that 2/8 is equal to 1/4. And because this is in a decimal form, it's easier to compare them in decimal forms. You should know that 1/4 is 1/4, similar to a quarter of a dollar, or a quarter is 0.25. So just here, in looking at these, I should be able to tell who's going faster. And it is Lynn going faster. So now let's go ahead and check all of our math by putting this into the graph is already done. I thought it would be far easier for you to see everything if I put this in here nice and neat so that you could see it. So the bottom one here, I would have preferred it if they had actually color-coded them, but it's okay, we can do that. This is Andre. We'll highlight Andre's in yellow. We know that they both started at 0. 0, 0. When 0 time had gone by, they'd gone 0 kilometers in this particular case. And the point that they gave us was 8.2. So when we connect that line, we would see that 2 is equal to 0.5. And then, of course, 1 is equal to 0.25. That's your k right there. And actually, I'm just going to make sure that you understand that that's k. And then if we go back and look at Lynn's, which we'll highlight in green, if we did the same thing to set this up with the information they'd given us, that Just want to redo that. There we go. With the information that they gave us, that Lynn had traveled 1.5 kilometers right there in 5 minutes, and we draw that straight line, we'll get right here, and we can see that 0.3 is our K. And again, Lynn is going faster. But let's always make sure that we understand that the line that's on top is always going to be the fastest than the ones below it, if there's more than one. But in this case, there's only two to compare.